Today we're going to do force in 1 hour. We're going to solve all the problem in force in just less than 1 hour. We're going to solve everything over right here. Let's create a space. Okay, this is number 1 force. And this is 10 kilogram. And as you see that, first we have to find from number 1, we are doing number 1. Mu s is 0.4. Mu k is 0.3. Now first we're going to find Fg. What is Fg? Fg is 98. I want you to tell me as I need the information. 98, okay? And what is the maximum opposing force? Maximum opposing force is mu s Fn. So mu s is how much? 0.4 times 98. 0.4 times 98 is how much? Quickly.
39.2.
39.2. Can you tell me quicker than that? So when you do the table, this is our table as you see over there. This is our table. We have FA, we have FNAT, we have FF, and we have acceleration. So FA is 5, 30, and 40 Newton, as you see that over here. Okay, is 5 greater than? Let's make it 40, and let's make it 50. Let's make it 40, and let's make it 50. All right, is 5 greater than 39.2? No. So what is the? So we first have to find force of friction, and then net force. Okay, is 5 is less than 39.2. So then force of friction must be what? Force of friction must be 5. Force of friction must be 5. Okay? Why? It's because Newton law. F equal to ma. Alright? The box will be at rest if you do not apply more than 39.2. So the box will be at rest. So at the x direction, how many forces, at the y direction, how many forces acting on it? At the x direction, how many forces are acting on it? FF and FA. So FA minus FF is equal to 0, right? So FA must be equal to FF. So if FA is 5, FF must be 5. Okay, so that's it. Now, net is equal to applied force minus force of friction. So 5 minus 5 is 0. So acceleration now, you're going to do the acceleration. Acceleration, Newton's second law, A is equal to F net over n. So F net must be 0 and A must be 10. 0 over 10 is 0. Okay, so now we're going to do the next one. Okay, now we're going to do the next one. Next one is what? 40. Is 40 greater than 39.2? Yes. So then we cannot use this formula. We have to use FF is equal to mu k Fn. And mu k is what? 0.3 times 98 is how much?
29.4.
So 29.4. So then what is the net force? 40 minus 29.4.
10.6.
10.6. Then what is the acceleration? Divide by 10.
1.06.
Okay, now let's do it 50. As you see that 50 is greater than what? 50 is greater than 39.2. So we must be able to use not this formula, the other formula. In fact, that force of friction will be same, 29.4. If I have 60, 29.4. If I have 1000, 29.4. Force of friction doesn't change, which I will use the friction graph to show you. F net, 50 minus 29.4.
20.6.
20.6 and 2.06. Okay, now I'm going to show you the force graph. So this is the force graph. force of friction. This is the friction graph. So this is the friction graph. This is FA and this is FF. Now I have the blue. This is, I have the blue. Let's draw the blue again. And then I have the red. Okay, so blue represent static friction, and the red represent kinetic friction. What is our static friction? Our maximum. What is the peak represent? Peak represent 39.2. What is FK represent for our problem? FK for this problem 29.4. FK is constant, that's why FK is the line. What about the blue? So Fs can be different, right? Fs can be different. If you apply zero force, then for static friction is 0. If you apply, for example, 5 Newton, then static friction is 5. So static friction can be anything between 0 to 39.2. But kinetic friction has to be only 29.4. Okay, we are done with problem number 1. Now we're going to do problem number 2. Okay. So now we're going to do problem number 2. So we're done with this one. Now we're going to do this one. So this one is so close, so I'm going to use this one. Alright, so first we're going to draw the force body diagram. So I'm going to put the box right here, and this is 10. So let's find this is FP. Let's do the only force body diagram. So force body diagram is, weight is how much? 98 Newton. What is the normal force? We don't know. This is Fy. This is Fx, because this one angle is 30 degree. This one has two components, Fy and Fx. This one has two components. Okay. Alright, these are the things. And then the friction, and then the applied force. Okay, so now let's first write all the equations. I'm going to first write the template. First I'm going to write F. So F cosine theta, F sine theta. This is equation number 1. And then I'm going to write equation for normal force. F normal is equal to Fg minus Fy. Then I'm going to write the equation for Ff. Ff is mu k Fn. Then I'm going to write the equation for F net. F net is equal to Fa x, don't forget that, Ff. And then finally I'm going to write acceleration is F net over m. Okay, now that I have the template, now I'm going to write the force. Force is 40, so I'm going to write 40 over here. Theta is 30, so now I'm going to write 30 over here. Okay, so now what is cosine 30?
Square root of 2.
Cosine 30 times 40.
34.64.
34.64. And this is 20. Okay? So now this is 20. This is 34.6. Okay. This is 98 minus 20. So this is 78. This is mu k. I have mu k. Mu k is 0.3. So 0.3 times, I have Fn. What is my Fn? Fn is 78. So what is it?
23.4.
23.4. Now I have Fax. Fax is not 40. Fax is 34.64. 34.64 minus Ff. What is Ff? Ff is 23.4. So what is this?
11.24.
11.24. Now I have F net 11.24 divided by 10.
Yeah, 1.124.
1.12. Okay, now I'm going to write everything I have. 34 0.6, one decimal place is fine. 20, 78, 23.4, 11 fine, 23.4, FF is 23.4, F net is 11.24, and acceleration is 1.2, 1.1. Okay? Now see, you're gonna use this template to do the other one. So I told you this is just a template. This is just a template. I told you this is just a template. So now what am I gonna use for this time? This time 40 over here. Okay? Now I'm gonna do 30. Okay? So I'm gonna do, this is 40. Okay? Now I'm gonna do 30. So 30. Okay, 30 cosine 30.
25.9.
25.9. And this is 15. Okay? Now this is 30 by the way. Now we are doing it for 30. Before we did it for 40. Okay. So now this Fy is 15. Very important. And this is 25.9. Okay, so what is my normal? Normal is 98 minus 15. What is it?
72.1.
72.
Wait. Oh. 98 minus 83.
83. Okay. Now mu k is 0.3 times 83.
24.9.
24.9. And FAX is 25.9 minus 24.9.
1.
What a coincidence. 25.9 minus 24.9. Well, 1. Okay, 1 divided by 10.
0.1.
0.1. Does that make sense? Yeah, that makes sense. Acceleration is less because the applied force is smaller. It makes sense. So we're gonna write 25.9, and then we're gonna write 15. We're gonna write 83. We're gonna write 24.9, and we're gonna write 1, and we're gonna write 0.1. Okay, so we're done with that problem. Now I'm gonna do only 2 more. Okay, now let's do the elevator problem. So now I'm gonna put the elevator over here. So I have the elevator set up over here. This is 200 and this is 100. Let's call this one is 1 and this one is 2. Alright, so let's do the force diagram first. I'm done with this one, so I can erase this. Okay, I can erase this. Alright, so I'm actually doing this one, problem number 3. Alright, now I'm gonna write M1 and M2. Okay, so this is 1. So force diagram, all the forces acting in the y direction. What am I talking about? This one, M1Z. This is F2. So M1Z and F2. Okay, this is the heavy one, so it's accelerating down. So minus A. Alright, and that's it. And let's do the other one. This is the 100 kilogram one. This is mass 1, this is mass 2. So this is M2Z, this is FT. FT, I'm going to write it in using same color. FT. I'm going to write FT using same color is because there is only one rope and there is only one FT. Okay? M1Z is not equal to M2Z. Okay? Alright, now this time acceleration is positive. Why positive? Because this guy is moving this direction. Okay? And this guy is moving this direction, that's where it is negative. Okay. Now I'm going to write Newton's second law to write the system of equation. So F equal to ma. Alright, so F should be replaced by what? Ft minus M2z is equal to M2a. Now I'm going to write F equal to ma here. Now I'm going to write Ft minus M1z is equal to minus M1a. Why minus? Because this minus. I'm going to make it this color so that you're going to understand why this is negative a, because this is negative a. Why this is positive a? Because this is positive. Okay, now I have two equations. I'm going to put them on top of each other. So let's pass this one, write this one. This one is ft minus m1g is equal to minus ma, and this one is ft minus m2g is equal to m2a. Multiply this one by negative. Let's multiply this one by negative. Negative, positive, positive. Okay? So I'm going to cross this one. So I have m1g minus m2g is equal to m. This is 1, m1a plus m2a. So what I basically I can have a factor, common factor, and common factor. So a is equal to m2 minus m1 over m2 plus m1 times g. Okay? So now what is m2? M2 is, what is m2? Oh, a is m1 minus m2. Oh, okay. m1 minus m2. Okay? So what is m1? m1 minus m2. m1 is 200 minus 100 over 300 times 9.8. So what do we get? 100 divided by 300 times 9.8. So 0.33 times 9.8. So 0.33 times 9.8 is how much?
3.23.
3.23. So the acceleration of this elevator is 3.23 meters per second squared. Now we can find the ft. So finding ft is just very easy. So ft is equal to m2g plus m2a. So ft is equal to m2 is 100 times 9.8 plus 100 times 3.2. So what do you get?
1300.
Altogether 1300?
Yeah.
1300. Alright guys, so we're done with that. Now we have only two more problems. So let's do this one first. This is 12 kilogram and this is 10 kilogram in 40 Newton. Okay? No friction. No friction. Okay. So first we have to draw the force diagram. Let's see how that how you understand that force diagram. We're gonna call it mass 1, we're gonna call it mass 2. So mass 1 and mass 2. Alright, so now mass 1 and 2 both are sitting on the table, as you see that. So at the y direction forces cancel out, so we're not gonna write them. At the x direction something is going on. So I do have ft over here, so I'm gonna write ft. That's it. That's the only forces acting in the x direction. Okay? I can write this one fg, and I can write this one fn. Alright, but there is no acceleration at the y direction. So now I'm gonna write f is equal to ma. Ma at what direction? X direction. At the x direction, how many forces? Ft is equal to m1a. Okay, it's acceleration to the east, so I'm gonna have positive a. Alright, now let's do the force diagram over here. This is fg, this is fn, and this is, I'm not gonna use red because this is fp, not ft. And if you, this is kind of ft, but ft would be different. This ft is different than this one. Okay, this ft is known, 40 Newton, and then this is our ft. This ft I'm going to write it in red because this ft and this ft are the same. Okay, so I'm going to write Newton's second law in the x direction, F equal to ma. So Newton's second law tells us F equal to ma. So at the x direction, how many forces acting on it? 2. Fp minus ft is equal to m2a. Okay, so I have two equations. Now here, as you see that, here now I have a system of equations. Let's put them on top of each other. So Fp minus ft, Fp minus ft is equal to m2a. And now I'm going to have ft is equal to m1a. Cancel. So Fp is equal to m1a plus m2a. So Fp is equal to, I have a common factor which is a m1 plus m2. Okay, so a is equal to Fp over m1 plus m2. So a is equal to 40 over 12 plus 10 is 22, which is 1.82, I believe. Alright, so this is our acceleration, meter per second square. Now let's find the tension. Tension is Ft is equal to m1, which is 12, and a is 1.82. Let me know whether or how much it is. 21 point how much?
84.
21.84?
Yeah.
21.84 Newton. So the tension over here, right here. I'm not gonna make it black. Let's use green. So this is 21.84. So now let's prove that. Let's prove that whether we get back to 40 if we use this formula. Fp is equal to, in fact, 40. Let's prove that. So Fp is equal to, Fp we already know Fp. So what is Fp? Fp is 40. So 40 is equal to 40. That's what we're trying to do. A m1 plus m2. So 40 is equal to, A is 1.8181. M1 is 12. M2 is 10. So 40 is equal to 1.8181 times 22. So 40 is equal to 40.
39.99.
Good. Okay? Awesome. So now we're going to solve the next one. So which one is the next one? Next one is number 5. But for number 4, I'm going to put the equation over here as for you to see it. M1 plus M2. So number 5, as you see that, a little different. Here, 2 boxes, both are sitting on the table. 1 box sitting on the table, 1 box hanging. 1 box sitting on the table, 1 box hanging. Let's make it 5. Make it 2 kilogram. Box number 1, box number 2. Let's put friction. Mu k is equal to 0.2. Okay? So now let's do the force diagram before we do anything. This is M1, this is M2. M1 at the x direction, M2 at the y direction. Why? Because this is accelerating at the x direction. This is accelerating at the y direction. Okay? So this one has to be what? Fz. Fz, to be more accurate, this one has to be M1z. And I want to find what is M1z. M1 is 5. So 5 times 9.8. So 49 Newton. Okay? And this one is, so Fn is 49 Newton. Okay? So let's write it over here because this gets too crowded. This gets too much crowded, and I don't want to put anything in the y direction. We don't care about the y direction for this one, only the x direction. X direction I have 2. One is FF, and I have this one, tension, FT. So I'm going to write blue, FT. This blue and this blue are the same thing because the one rope, only one tension force. So let's write Newton's second law. And acceleration, this is acceleration to the east. So acceleration must be positive. This is accelerate toward the south. So that must be negative acceleration. Okay, good. So F equal to ma. Alright, now F is what? Ft minus FF is equal to M1A because this is M1. Now let's do this one. Where is ft? This is, we have to do at the y direction because it's accelerated at the y direction. This is ft, so I'm going to use the blue ft. This is m2g. So I'm going to use Newton's second law. So I'm going to use the different approach. Let's not use this approach. Let's not say, well, this is accelerating downward and use that. I'm going to use the different approach. F is equal to ma. There are two ways to write it. Number one way is making ft minus m2g is equal to negative ma. It's because this is negative m2a. Or you can write m2g minus ft is equal to ma. Then you don't have to negate it, okay? All right, so you can do it both ways. So let's do it the way that is make more sense. ft minus m2g is equal to minus ff is equal to m1a, and then ft minus m2g is equal to minus m2a. Okay, so negative here is the problem. I cannot put it like that because these are not like terms, but it doesn't matter. So what I'm going to do, I'm going to negate this one. I'm going to multiply it by negative. So this negative become positive, this negative become positive. So look what happened. Is this cancel? I'm going to write the positive term first, m2g, and then I'm going to write minus f. Then I'm going to write m1a, and then plus m2a. Okay? So now I have the common factor here, which is a, m1 plus m2, and I have here m2g minus f. So I will solve it for a because that's what we do to get the acceleration m2g minus ff. This equation is a whole lot like this equation, except the friction, because we consider no friction over here. Alright, so acceleration is 2 is 2, 9.8 minus ff is 9.8 over 7. 7 is because pi plus 2. So 19.6 minus 9.8 over 7. So 19.6 minus 9.8 is, I guess, 9.8, right?
Yeah.
Divided by 7 is how much?
1.4.
1.4. So acceleration is 1.4. Exactly 1.4?
Yeah.
So acceleration is 1.4. Now we're gonna see how much is the tension force. So we have two formula to calculate the tension force. One is this one is that one. So we're gonna check both. So Ft is equal to, both of them has to be same. Ff is 9.8. M1 is 5 times 1.4. So Ft is how much?
16.8.
16.8 Newton. So let's see whether it is close to 16.8 here. M2 is 2, 9.8. Minus M2 is 2, 1.4.
Yep, 16.8.
16.8. So what a magic, okay? Alright, so physics is magic, okay. So now we're gonna do our last problem. So physics in less than 1 hour, force is less than 1 hour, not a joke. So make sure you guys understand all the topics covered in this video, because I'm doing this video with 104-degree fever. I can barely talk because I have a pain in my throat, but doing it because there is nothing better things to do. So I will show the proof of the formula of the incline. So incline is 30 degrees. As you know that the mass doesn't matter. Acceleration is independent to the mass. Acceleration is independent to the mass. Okay, mass doesn't matter. Okay, now what I'm going to do, I'm going to put the mass. Why I'm putting the mass? Because just to show you the force body diagram. You want to find the acceleration. That's what we want to find, because the box is sliding down. All right, so let's fast put it that way. Degree is 30. We know that. So this is gravity, Fg. Now we want to put the the y component. So this is the y component which is perpendicular. So this is Fn, this is Fy. Now we're going to put the x component. The friction, let's say friction is 0.2. Okay. Alright. So friction is 0.2, which I will use it. This is force of friction. Alright, this one no good. Alright. There is another one? No. Okay, there is nothing. Okay. So now I'm gonna bring this two, black, the green and the blue down here. So let's first draw the black one. Here is the black one. And then let's draw the green one. Green one. And then let's draw the blue one. Blue one. So what I have essentially is a right angle. Okay? So black one is what? FG. FG can be called MG. So I'm going to call this one MG. The blue one called, oh, by the way, I forgot to write. Blue one called FX. And the green one called FY. And this is the angle. Okay, this is the angle, which is 30 degrees. Because if this is 30, this is 30. Okay? Alright, this is the theta. So calm. We don't have to deal with true up. So sine theta is opposite of our hypotenuse. So sine theta is, what is opposite? Fx. And what is hypotenuse? Mg. So Fx is equal to mg sine theta. Cosine theta is Jason over hypotenuse. Okay? So cosine theta is, what is Jason? Fy. What is hypotenuse? Mg. So Fy is equal to mg cosine theta. Okay? So Fy is equal to mg cosine theta. Fx is equal to mg sine theta. Fn, if Fy is mg cosine theta, this is also mg cosine theta. Ff is equal to mu Fn. So this is mu mg cosine theta. Okay? Alright, now we are ready to calculate by using Newton's second law. Newton's second law said F equal to ma, of course. F equal to ma. What direction? Acceleration. X direction. X direction, two forces. Fx minus Ff is equal to ma. Fx, we already says mg sine theta. Minus Ff, we said mu mg cosine theta. Is equal to ma. As you see that mm cancel. So what we left with essentially is g sine theta minus mu g cosine theta is equal to a. G factor out sine theta minus mu cosine theta is equal to a. Alright, so g is 9.8. Sine theta, sine 30 degree minus mu is 0.2. Cosine theta is cosine 30 degree. So this is our acceleration. So 9.8 cosine 30 degree is
square root of 3 over 2. Oh, sorry. The total thing?
no, just cosine sine 30.
Oh, half.
Sine 30 is half. Minus 0.2. Cosine 30 is 0.87.
0.87.
Okay. So acceleration is 9.8. 0.5 minus.
So let me see. 0.2 times 0.174.
0.174. So acceleration is 9.8 times
0.5 times 0.74.
just what is the acceleration?
Yeah, that's 3.19.
3.19. So acceleration of this system is 3.19 or 3.2. Acceleration is 3.2. So that's how meter per second square. So that's how you're gonna find the acceleration of this system. Okay, guys, make sure you watch this video as many times as it takes for you to understand it. If you have any questions, just write down the comment below the video so that I'll answer it immediately, almost immediately.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.